This is 5.4 exponential and logarithmic equations. So we're going to solve a lot of equations here, example after example. So here you have a couple ways to do this problem. Here, the last two sections we've talked about if the bases are the same, then the exponents are the same. So you can literally just set the exponents, since they have the same base, you can literally just set this equal to one another. Then factor. So x equals 4, and x equals -1. Now, I want to emphasize this. You should always check your answers to make sure they work. All right, sometimes even though I got two answers, doesn't mean both of them actually work. So just a general suggestion, you always check your answers. Which, by the way, both of those did work on that problem. All right, so here, again, we're trying to solve for x. So x equals what? So what we need to do is to isolate the variable here as much as possible. We need to solve it. Now, a big mistake a lot of students will start doing, this is wrong, but a lot of students will multiply and put 6 to the x power. That is not 6 to the x power, okay? You can't multiply those. So what we have to do is get rid of the 3. So we're going to get rid of that 3 by dividing by 3. So now we have 2 to the x power equals 14. Now, how to solve it from here? Again, there's multiple ways I could show this to you, but one way to do this is if you think of log form. So this is log base 2 of 14 equals x. So you can easily do it that way if you want to do it that way. Remember the counterclockwise. So you could do it that way. Or another way to do this is a basic rule in Algebra 1 is what you do to one side of the equation, you do to the other side. Well, what we're going to do, since we're on a logarithmic chapter, we're basically going to take the log of both sides. Remember, what you do to one side, you do to the other side. Now, if you do it this way, remember one of the one of the properties of logarithms, if you have an exponent, it actually comes out front. And then all you have to do is simply divide those sides by log 2. So x equals log 14 divided by log 2. Now remember, this right here and this is the exact same thing. Remember the change of base formula. So either way, you can just calculate this on your calculator and get your decimal answer. And then, round it to, 3 decimal places, 4, whatever the instructions say. All right, to solve this, again, our objective is to get to x. So we're going to first minus 5. So e to the x power equals 55. And once again, there are multiple ways to solve this. One way you could do this, again, is log base e of 55 equals x. And again, I want to keep saying that counterclockwise, e to the x equals 55. So you could set it up that way. And just as a reminder, log base e is actually ln. So ln of 55 is x. So all you have to do is plug that into your calculator. Just ln of 55 and get your decimal approximation. Another way to solve it, though, is, again, what you do to one side of the equation and do the other side. So we're gonna take the ln of both sides. And you're saying, well, why ln? Why not just log? You could just do log, but again, log of like log base e, you could do that. As a matter of fact, you literally could do that, log base e of both sides. Literally choose the base, which is log base e. And remember, one of the properties of if those match, the answer is that. It's just x. So here, back to this way. So I showed you one way to do it. I showed you a second way to do it. A third way to do it is just take the ln of both sides. So ln and e, remember, they're inverse functions of each other, so they literally cancel each other out. So again, I showed you 3 different ways to be able to get to your answer to solve that equation. It's totally up to you which method you want to use. Here, again, we want to solve for t. Notice where t is located. It's located up in the exponent. So we got to use the right algebra steps to solve it. So first we're going to add 4 to both sides. Then we're going to divide both sides by 2. Once again, there are multiple ways to be able to do this equation to solve it from here. So again, I'm going to show you 2 different ways, and you can choose which way to do it. So you could do log base, think of it counterclockwise, so log base 3 of 15 halves equals 2t minus 5. Remember, 3 raised to that power equals that. So, and then you can easily solve that. Add 5 to both sides. So log base 3 of 15 halves plus 5. And then that equals 2t. And then all you have to do is divide by 2. So this right here, if you plug all that stuff into the calculator, it's going to give you the decimal approximation. The other way to do it is simply just take the log of both sides. So you can take the log of both sides. Remember, what you do to one side, you have to do to the other side. Remember the property of logarithms. If you have an exponent, this right here, we're going to literally take that out front. So literally 2t minus 5 times log 3 equals log of 15 halves. Divide both sides by log 3. Now you have 2t minus 5 equals log of 15 halves over log 3. Then just add 5 to both sides, and then divide both sides by 2. So again, you're going to have log 15 halves over log 3 plus 5, and all of that is being divided by 2. So again, either way, you would have to plug it into your calculator to be able to get it. But these two are the same thing. Again, and then round it to 2 decimal places. All right, now to solve this one, if you notice this, you're like, well, how do I isolate this one? Because now I have 2e to the something power. Well, if you just glance at it for a while and just stare at it for a while, you'll notice that it resembles, if I had like x squared minus 3x plus 2. See, it resembles that same pattern. And this factors to x minus 2 and x minus 1. Which means x equals 2 and x equals 1. Now, so we're going to do the exact same thing. So instead of x minus 2 and x minus 1, this is e to the x, and then minus 2, minus 1. Again, multiplied like bases, you add the exponents. So then you're going to solve this, e to the x minus 2 equals 0, and e to the x minus 1 equals 0, which again means x equals 2, e to the x equals 1. And then to solve that, you're just going to ln both sides. Or, what I would do is just ln both sides. Ln, e, they're inverse functions that cross each other out. So x equals ln 2. And here, again, they cross out, so ln 1. And then, again, you can punch those in to your calculator and get your decimal approximations. All right. So let's look at this. Again, it looks kind of simple. Again, there's multiple ways to solve this. But I would, again, I've said it multiple times, to get rid of the ln and e are inverse functions. So I would literally take e to both sides. That's really what I'm doing. And so these are going to, inverse functions are going to cross out, and I'm just left with x. X equals e to the 3rd power. And again, just plug that into your calculator and get your decimal approximation. Same thing here, discussed earlier. We had log base 3, log base 3. They're both equal to one another. So that means 5x minus 1 equals x plus 7. And then you can easily solve this. But I want to say it again. I've said it at least once. Make sure you always plug it back in to make sure it actually works. Now, on this one, you're going to have to think about what all of this means. So notice the left side of the equation, okay? So here's the left and the right side. So the right side, I'm just going to leave it alone for right now. The left side, notice it's the subtraction of two logarithms. Well, I'm going to condense that to one logarithm. Remember, the subtraction of two logarithms is the same thing as the division of one. Now, once I get down to here, notice I have log base 6, which means 3x plus 14 over 5 equals 2x. From there, it should be pretty easy problem. So 3x plus 4 equals 10x, 7x equals 4, x equals 4 sevenths. Here, minus 5 from both sides. Divide by 2. Get rid of the e, or to get rid of the ln, I'm going to e both sides. And again, these cancel each other out. So e to the negative 1/2. Again, just plug that into your calculator and get your decimal approximation. All right, so look at this one, very similar. Divide both sides by 2 first. And again, multiple ways to do this, but what I would do on this one is do that inverse or the counterclockwise motion. So this literally is 3x equals 5 squared, or 3x equals 25, which means x equals 20. Pretty simple problem, as long as you know the properties. And then last problem, you deposited $500 into an account with 6.75% interest compounded continuously. How long before you double your money? That's an important thing. So notice one of the ways we remember, since it says continuous, we're going to use the formula P equals RT, and we want to find out when that will double the amount that I invested, which is $1,000. Double that. So here we have 500. E, the interest rate is 0.0675 to be able to do this. And T is what we don't know. We're trying to find the time. So this step, make sure you set that up, because I'll look at each step and give you partial credit and make sure you know how to do it. But setting that step up is crucial to be able to solve it. All right, so divide both sides by 500. Put an L in both sides. Remember, the L and the E cross each other out. So 0.0675 T equals ln 2, and then just divide both sides by 0.0675. So if we come over to the calculator, ln of 2, 2 divided by 0.05, and so the time is approximately 10.3 years for your money doubles. And that's how to solve exponential and logarithmic functions.